Good morning, everyone. Yes, sorry, it's been a bit of a day today with all the protests and so on. So the following recording, this is what we basically what I wanted to cover in today's lecture. It's not a lot of work. It's mostly theory. Just before we actually get to the next section or unit, so we're basically at the end of unit 3, so we're actually a little bit ahead of where we were last year with everything, so we're doing quite well. I just wanted to discuss one or two things for you for your task submission. This is just some of the notes that I saw from last year, and the feedback that I gave the students then was please note there's a couple of things that you need to just make sure. You have to do a little bit of research on the professional team and what is the professional team. The contractor doesn't usually form part of the professional team as such in legal terms. The professional team or the consultants are usually the advisors on the client side. So the professional team is usually your architect, engineers, QSs, health and safety consultants, and whoever works on behalf of the client. You may mention the contractor as part of the team, as the in the terms of not the professional team in the name of profession or professional on the team. You may refer to him as part of the professional team in general sense, that he's part of the team and so on, but in general terms, in legality, he's usually not part of the professional team. So just make sure that you make that differentiation, because I'm also looking at that understanding from your side. You need to show me that you understand this is the professional team on the client side and this is the contractor on the other side, and so I want to see that. Then also just make sure that you show where you got your professional or your historical data whenever you're doing your rate build-ups for your estimate. And then the difference between last year, I just saw that there not everyone distinguished what's the difference between a civil engineer and a structural engineer. So please make sure that you understand what the obligation of each one is. I'm not going to give you the answer on it now. You need to do some research on exactly who and what the civil engineer and what the structural engineer does on the project. It's not just the engineer. What does the electrical engineer do? What does the mechanical engineer do on the site, so on the project? So have a look at that so that you can actually differentiate and give me proper insight into what each one does. And then we have our health and safety consultant. Okay, don't forget about him, becoming more and more prominent. Yes, I just saw last year a lot use the AECOM report. Yes, that is okay, but I would not use the AECOM report to do my estimate for the rates. I will only use the AECOM report to compare the rates that I do use when doing the calculations for the estimate. Okay, and then have a look at whether you're including your external works, where, and is everything included to make this project work. So just have a look at that. Okay, and then plagiarism. There was one or two sections last year, one or two students where it was a bit of suspect, so please make sure that you are aware of that. Don't copy from each other. I know you can collaborate, but please don't make the same mistake. You can work together, but you still need to interpret it by yourself and put it on paper according to you, that it's your interpretation of that group work that's being put to paper. So please make sure of that. Okay, and then just have a look at your tenses. Always write in the third person, don't write in first person. Yeah, these things I think I won't struggle too much. It was only one or two last year that popped up but not many of them, so just make sure that you've got that. Also, and on that note, also make sure that you do your referencing correctly, reference list, in-text reference as well. So please make sure that you do that, and that you tick all the boxes of the rubric also. Okay, so yeah, so please have a look at that. And then coming to today's lecture, we're going into the next part of we're on the fringe of unit 3 and 4. So we're looking at chapter 5 of the study notes, and next time we're going to look at chapter 5 of Maritz and Sichli, which is the crossover between the estimate stage and the actual implementation of the project, going out on tender, the procurement side of it, and actually getting a contractor on site. So we're kind of at that stage at this stage. So just to show you visually, we've done all of the estimation methods for stage 1, 2, and 3, and now we're getting to the detailed estimation part. So the detailed estimation parts is kind of where we are now. So this section and between this section is what we're going to look at now until the end of the semester. So we're going to cover this, and then next semester we're going to look at the payment certificates and the actual implementation, and then the close off of the project. So we're going to look at that, so please be mindful of that. And yeah, so the next few slides and the recordings are basically on the theory, so please just make sure that you keep up to date. It's not a lot of work, you can read through it as well, and then next time when we see each other we'll just elaborate on that. Thanks everyone. Okay, so chapter 5 of our study notes, it's not a very long chapter. You will see, although we've discussed the elemental cost estimate, so we're going to start with our elemental estimation. We've discussed the elemental cost analysis method on elemental and component level. They are more or less the same method. The data behind it all is the same, but it's the detail, like I've mentioned before, that we're going to look at. So the application differs. That's the main thing, is with up to component level, is we're going to look at each and every component. So it's being broken down further and further. Okay, so the total elemental cost is derived from the sum of all the applicable components. Okay, there's specific units for measurement, e.g. our strip footing is measured in meters. Okay, so we'll still get into this, how this works, but basically your this meters is then broken down further in our bills of quantities into cubes, and then the specific items. So your elemental estimation, you basically measure the length of the strip footing, but in your bills of quantities, that length of strip footing is broken down further into the different elements, like the excavations, the carting away of that material, the backfill, the blinding of the concrete that has to go in, the actual concrete that goes into the strip footing, and then the building up of the brick walls in the foundation, backfill to that again, the compaction of that, etc., etc. So that is something that you need to remember, is your elemental estimation groups item like strip footing into one, and where your bills of quantities actually breaks it down even further. Okay, so I don't want to go into it too much, but you will see later on in the presentation how that works. There's a standard method of measurement. This is very important, and I'll still share the standard measurement system with you that you can use when you do your task. Okay, so the advantages of this, the elemental a method up to component level is the structures and standardized, easy to interpret by others, because it's guided by a guideline. Any person that picks up that measurement will have a rough idea, or will have an idea of where all the components came from and how it was measured. There's specific rules of how items are measured, or the components are measured. Far more accurate and design details required, and is regarded separately, and an elaborate historical unit tariff is used. So and you can use old projects, usually bills of quantities, to determine your historical rates. It is suitable for cost analysis. It shows how building costs are distributed over different building elements, and how it is spent over within each of the elements, thus suitable for cost control. Very good for cost control, actually. Okay, so the advantages, or disadvantages, pardon. It's more time consuming. Obviously, you're now going to measure each and every component. Detailed information pertaining to all components should be available. Okay, more complicated, and not all item tariffs can be converted to units. Thus, some components, global historical components costs are needed. So you need accurate information to actually build up these rates. But what is nice about this is you can actually get new rates. For instance, you can go to builders and get the cost of a toilet, and add your installation cost, add your profit, and so on. So what's nice about it is, whenever you've got a new item, you can build up your rates through this. Even though it is a disadvantage because it takes more time, you can get quite accurate information like that. Okay, so the possible applications, time is the biggest disadvantage. By applying for it and allowing certain items of small value to be calculated together with certain components. For instance, strip footings, skirtings, tilings, etc. Like I've explained earlier, you're grouping items together to be measured. Okay, so for instance here I just added some edge trims, can actually be included in your tiling. So for all floor installation. So whenever you're doing a floor installation, you will measure the specific type of floor over a square meter area, but it will include the installation, it will include the trims, it will include the cutting, etc. It will include, you can include the skirtings into that, etc. It is for processing of data and detailed sketch plans and construction drawings, and should be applied to these stages. Okay, although if combined with the component, it can be a very quick method to use, especially if you've got a template set up. It can be very quick and easy to actually do your estimation. It can be applied very early on. For instance, my experience that I've had is I've done elemental estimations without having not having much information, and then basically using a previous estimate and speaking to the architect and asking what type of finishes there should be, etc. Would it be similar to this type of development? And then from that you actually have most of the specifications already with the costs available. So you can actually do elemental estimation very early on. It just means that the design area is a little bit falls a little bit more towards the QS to actually assist with the design of the types of finishes. Okay, so that's more or less the theory on the elemental method up to component level. The next one that I'm going to talk about is the comprehensive quantities. Now, the comprehensive quantities is almost like your balls of quantities, but it is more the quantity surveyor basically uses balls of quantities, but then he groups it according to his understanding of what information he's got available, and putting a basic bill together with items, but then making allowances for the items that he doesn't have. So it's a it has a lot of items, but it doesn't reflect a true and accurate measurement of the entire building. Okay, so you have different purposes. It's cost estimation. It can be used for tender purposes. So for instance, a QS will use a old bill of a similar type of building, measure the amount of items, but it's all remeasurable, making allowances for items that might not be measured. It's usually over measured a little whenever it's used. It can be used for cost purposes. Estimation differs slightly from the elemental method on component level, in the sense that not all information is measured into exact detail. Okay, so the component amounts are mainly subdivided into item amounts and measured sections instead of elements, namely measurement sections. So if we go through that, you've got your foundations, structures, your walls, your roofs, exterior finishes, interior walls, floors, ceilings, windows, and your accessories. And the main difference here is you measure items instead of components. So you measure specific items in the bill instead of breaking them down or grouping them in your different sections together. Okay, for estimation, the following general approach is used. For estimating purposes, there is a certain way of measuring items. Quantities are calculated in detail. Items are grouped. Okay, so certain items are grouped within the previous slides groupings. Diverse items of little value is included in applicable tariffs, e.g. soil tests and shop drawings. So all of these allowances is made. Items of the same dimensions of same production are grouped together. Items of different dimensions in the same production process are grouped and measured as extra over, for instance your doors and your windows. And allowances is made for unforeseen circumstances. Okay, so the advantages is that it's more accurate based on real quantities, and thus global historical cost is less important. The costs are grouped in certain sections and suitable for cost analysis, and the quantities are determined in a structured way, standard system. Okay, so it still follows the rules of the standard system of measurement, but it doesn't follow a strict rule of dividing your measurement into different sections. Like for instance, if you've got a bills of quantities, you will have different buildings maybe on one project, or different sections of a build project grouped together, whereas the comprehensive method will probably group everything together at first before actually taking it out further. Okay, so the disadvantages is the aim is calculating cost and thus time consuming. Detailed information is needed, not as structured as the elemental method, and thus difficult to establish a uniform system. To save time, shortcuts are used, mainly grouping of items. rates have to be kept up to date constantly. Yes, so this is the disadvantages of this. So to be honest, the comprehensive method isn't used that much in practice, because it's more or less but it falls between the elemental estimation and the bills of quantities. So for instance, myself, I'll rather do an elemental estimate and then immediately jump to the bills of quantities instead of doing a comprehensive method or quantities method, because all that it means is that you have to you measure it quickly, but then you have to remeasure your the works again whenever you do your bills of quantities. So it's not a method used very often, but some QSs does, instead of using the elemental method, they use the comprehensive method, and then they use to save them time. They just either use the elemental method or the comprehensive method. Okay, so possible applications: detailed construction drawings are needed. Through grouping, it can be applied earlier. Okay, obviously you need some experience to do that. It's suitable for to complement other estimation methods. Okay. Okay, so our final method that we're going to discuss today is our accurate quantities. Now, this is your bills of quantities. Now, this is the item or the method that we get to, that we go out on tender with. So, usually, if all goes well, all the designs are done, all the finishing schedules are done, the engineers had their go at the designs. You know how the building is developed, or how it goes, and basically all of the information is available. So the QS can now go through the drawings and the designs systematically and build the structure within his head, or nowadays on Demex, or use the model, and then put himself in the shoes of the contractor, and then systematically note everything down, so that a contractor can actually price each item, and then the QS can monitor the contractor against that. Okay, so accurate bills of quantities are done for contracts with bills of quantities. So it will become a contract document, part of it. It is usually done on the standard system of measurement work. Very important, because now it becomes a legal thing. If, for instance, I say that excavations of your strip footing, for instance, does it include carting away of the excess material that's not going to be used again, or is material just worked into over the site, or what do you do with that excess material? Or another thing, for instance, hard rock. If, for instance, you have excavations, but you find that there is hard or rock that has to be either blasted or chipped away or whatever, how do we pay the contractor for that? So it's very important to know. So that's why the standard system has been developed to say how each and every item will be paid. Another example, for instance, if you install your tiling, what does it include? Does it include the grouting, or is the grouting measured separately? What width of grouting is used? Because if you've got a large quantity of tiling, and the difference between a 5mm and a 3mm grout can have a big impact on the amount of labor and the amount of grout material actually used on a project. So that type of items is governed by a standard system of measurement work. So whenever there's a difference between the contractor and the principal agent, one can go back to the standard system and see how these items are actually measured and how they actually are paid for. The exclusive exclusive purpose is to attract competitive tenders. Okay, so the bills of quantities actually gives the opportunity to for contractor to price a bill accurately. Then the price BOQ is the last estimate before the actual quotes are received and should be very accurate. Okay, the price BOQ can be used to determine rates for other means of estimation. Okay, so for instance, your elemental estimate, whenever you've got your bills of quantities and rates priced in them, then you've got a lot of nice information that you can use on your elemental estimate again. It reflects market rates of different items in a specific period. Okay, very important. And yeah, so that's more or less the overview of the bills of quantities. In our next lecture, we're going to go into that a little bit more in detail. I'm going to show you how the bills of quantities, the columns, and the structure of bills of quantities actually works, and that will explain a little bit more on how the actual system works. So thank you everyone, and that's today's lecture, and yeah, keep well.